Alright guys, going to go over a little bit what you had to do for homework last night. Not going to spend a ton of time on it. And as I said yesterday, if you need to skip this part and just check for the answer, it's fine. That's what I'm wanting you to get out of it. But just in case somebody struggled with it last night, I'm going to go through the basics of it here and then skip through and figure out what it should look like. But the important part out of it is not having the final answer, it's knowing how to find the final answer. So just like we went yesterday going through this, most important part is to find the smallest number, which is right there, 145. So we have 5 as our leaf. We have the 140 for our stem. I know that's a little hard to see. Sorry about that, guys. It's the copy on there. Go cross that out. Go to your next largest number, which happens to be right beside of it. It's 147 again. Change the finger there, it's a little easier to see. So we don't start a new stem, we just write the leaf beside of it, cross it out. Generally a good idea just to cross it out, not to scribble it out, because if you scribble it out you might need it later. And if you scribble it out, harder it is going to be to read. Go to your next one, which is going to be 151. So we put 15 as our stem, 1 as our leaf, cross it out. We go to 152, we have 3 of those. We have to put a 2 for each one. 152, 152, 152. What's going to happen when you're done, you're going to have a leaf for each number you have here. So you'll have 30 leaves when you're done. And a good way to check yourself and make sure you didn't miss one is to actually count them. Then we go up, still going each time, adding a new leaf for each one. I'm going to skip ahead here and go to the answer. If you're still having trouble exactly where I was coming out with that, feel free to shoot me an email and I'll give you a more in-depth explanation, but it seemed like most of you knew what you were doing. So, skipping ahead to the answer. Alright, so I've jumped ahead to the answer here. Again, sorry, it's a little hard to read. That's the best I can do with that. But again, making sure you've got 30 numbers up here, making sure you have 30 leaves, so you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, so on and so forth. You have 30 of those. You might want to pause this for a minute just to double check so you can actually compare and make sure your answers are the same. A couple things I want to point out. Notice I've got zeros here for 160 and 180. Some people want to leave those out. Make sure that you have multiples for those that are multiples. There's 2 7s here, multiple 3s, there's multiple 9s on that one. So make sure you've got all of those things in there and double check that. Again, you may want to pause that and actually check and make sure it's right, so you can also correct any of them you need to. So now we're going to look at what we're going to use this information for, and you can tell a lot of things from a stem and leaf plot. That's one reason we use it to organize things. So we're going to look over here to the right, looking at what is the total number of students. Well, the way we tell that, these were the heights of those students measured. So if there were 30 heights, there are going to be 30 students. And that's going to be our answer on that. Zoom in a little bit so we can see it. Don't make anybody motion sick there. So we got 30 students. It's the height of the smallest student. Well, coming back to that, we're going to look at the chart. And the smallest student is obviously going to be the one that's the shortest. So we're going to the smallest value here, where our 5 is. And remember that 5 stands for 145 centimeters. So we're going to go back to our question. And we're going to remember to use our label. So 145 centimeters. Then we're coming to the most frequent height. And remember, most frequent, that's going to be the one that appears the most often. So we're going to look for the number that has the most leaves in the row. So not that the number 7 itself appears, but the number 147 or whatever it is we're looking for. So we're going to go back to our chart. And what we're doing is we're looking for which row has the most of the same number in it. Going across is going to be the one that appears the most times. So going along, and it appears we've got 3 2s here. So 152 appears 3 times. You got 2 7s, no repeats on that one. You've got 2 9s. So it's looking like 152 is going to be the number we're looking for there. So 152 centimeters goes there for number 3. Now we're looking for number 4 here. What's the difference between the tallest and shortest student? So first we have to go back to our chart. We have the shortest student over here, but we need the tallest student. So we're going to go back to our chart, find the tallest student, which on here, if we look, is going to be the largest numbers down here at the bottom, stands for 192. So we go back to our question over there. And we do 192 minus 145, which is the shortest student we found earlier. And we get a total of 47 centimeters, which we put here, 7 centimeters. And something I want to point out right here that's a little hard to see on mine, but is a little easier to see on yours, is this is called the range. And that's an important thing. You might want to highlight that or mark it some way so that you know that, because you're going to see that term again and you need to know what the range is. So all it is the biggest value minus the smallest value. It's the distance between. All right, so back to the wide view here. We're going back to our bottom section here for our notes, stem and leaf plot. So I'm going to zoom in a little bit here so we can read what's going on. So a reminder at this point, anytime you know what's going on here and you can read for yourself, you don't have to listen to me. You can skip around, but any of those that need that and want to follow along with what I'm doing, feel free to do so. Stem and leaf plot. Rotate the page with your stem and leaf plot 90 degrees counterclockwise. That's the way the clock doesn't go. So that the leaves go up instead of to the right. The way in which the data is distributed or spread out is the distribution, and we've got some generic patterns. So what's going to happen is you actually look at how the numbers are grouped together, and if they're nice and even, so they group right here in the middle with almost all of your values, and they taper off to each side, you got it symmetric. If you got them kind of grouped over to the left, it's skewed right, and I know that seems backwards, but we'll talk about what we're talking about in a minute when we talk about skewed left and skewed right. If they're all grouped over to the right side, it's skewed left. And it's wanting us to actually write what type of distribution does the height data have. So we're going to go up to our graph, our stem and leaf plot. And what it said it wanted us to do is to actually rotate it counterclockwise 90 degrees. So I'm actually going to do that. So 90 degrees. And we're looking at our data. So if I were to, and you don't have to, but you can if you want, if you were to actually take and to draw a curve over that, and we were to find the line that's the center, if we were to draw that line in, we see that the data actually groups to the left of center. And it's maybe not 100% obvious when you first look at it, but actually tracing it like that a little bit, actually finding that center line and seeing, shows us that this is actually skewed right. So we're coming back to our question here. We're actually going to mark that it's skewed right. Oops, if I spell it right. Because our graph most matches that one there as we did it. That last one's going to be something you can answer on your own, but when we're talking about the table, just so that you're clear, we're talking about the information it gave you up here. We're actually talking about that right there when we're talking about our table. So answer, which one's it easier to see whether it's skewed? This group of data right here or our stem and leaf plot? So again, going to our wide view so we can see what's going on here. I'm going to this bottom square down here. We're going to talk about skewed for a moment, and I'm going to zoom in so you can read what's at the bottom. It's on the bottom of yours, and I am going to read it to you so if you can see, but I'm going to explain a little bit, so if you don't know exactly what I'm talking about, you can follow along. But again, remember, any point in time during this video, if you're saying, I've got this, I don't need to listen to Mr. Mitchell yammer on, feel free to skip around a little bit. So down here we've got our distribution. We're talking about, symmetric, skewed left, skewed right. And I use a little bit different times about talking about negatively skewed and positively skewed and normal. You can also think of it as symmetric, skewed right, and skewed left. Another way to think about it. But what it actually has to deal with is your mean and your median. And we're going to talk about how to find those. So don't worry about that if you don't know exactly what those are, or you don't remember what those are at the moment. So we're going to talk about what they are and how to find them. But right now, know that for them to be skewed symmetrically, the mean and the median have to be equal. And that doesn't happen all that often. There's normally at least a slight skew with the data, so keep that in mind. But they've got to be equal. Positively skewed to the right, or skewed to the right, means that the mean is greater than the median. Means the mean's going to be over on this side and the median's going to be up there. Negatively skewed or skewed left means the mean is less than the median. So if you skipped ahead, hopefully you stopped around this part or a little further ahead as you saw I'm about to draw some whales. And it helps you remember that which skewed left is, what skewed right is. And the way to do that, I tell people something to help them remember. Is down here at the bottom, the mean whale hits you with its tail. What that's designed to help you remember is which end the mean is on. So if you think for a moment, this is a whale coming out of the water, and I'm going to ask you to excuse my artistic ability or lack thereof for a moment. So if we assume that's a whale tail down here, the mean is with the tail. You notice down here you got mean on the right side, the tail on the right side like the whale's coming up out of the water. So that's skewed right. The tail's on the right, skewed right, mean is to the right. On this side you get the same guy again. Your tail's on the left. The skew is to the left. The mean is on the left of the median. Okay? Some people want to draw a whale in the center to show they're symmetric. If you want to do that, the tail is actually going to come up behind the whale because they're equal. And again, I'm asking some forgiveness for my lack of artistic ability there. That whale looks more like a ghost than a whale. But these guys down here are kind of whale-shaped as the whale was coming up out of the water. And that's something I've used to help people remember which direction the skew is to and which direction the mean is on. Because sometimes people have trouble remembering. It seems a little backwards to some people. That's completely understandable. So I would jot that down, maybe draw myself a little picture, and maybe an explanation would be very beneficial. All right, at this time, the back side of the notes are intended for additional practice. What I'd really like for you to do is to actually try this. Do this right now. What I'd recommend is go ahead and pause this video and go ahead and dive in, because at this point you've been listening to me for a while. Go ahead and take the time, pause the video, stretch your brain just a minute. Go ahead and try these and start it again to double check and just make sure you did it right. All right, so here are the answers for this first slide here. Go through a couple things real quick. Won't read it all, just making sure you've got an understanding. One that tends to throw people off is when there is only something in the ones place. We're using the ones place as the leaf on here because it's the smallest place value, and that's what we're talking about over here when we answer that question, how do we know what to use as leaves, is that we use the smallest place value. They're common in all of them. In the ones place, there's an 8, but it's just an 8. So we have to have a stem of 0 because there's nothing in front of it, and we've got to have that placeholder. So that's something important, and a lot of people will miss that or it'll confuse you. So if you fell in that category, don't feel bad. You're, in a fairly large crowd normally. That tends to be what confuses people. Rest of them are fairly similar to what you did, so hopefully it wasn't too confusing. How do you know what to use for the stems? You use a placeholder or whatever is left in front of your leaf. Now you know what to use for leaves is you always use the smallest place value common in all of the data points. Questions that could be asked about the data, lots of them. I gave you 3, said how's the data skewed? What score appears the most? What's the range of the data? These are a couple. You could certainly ask other questions, and if you had other ones, those are probably appropriate. If you only put one question, I want to put in there, I want to draw your attention to the word questions. It's plural. They're wanting at least 2. So if you didn't put 2 on there, put another one. So for the second slide here, looking through, I made the stem and leaf chart over here. Hopefully yours matches up to what I've got over here. Answering the questions, highest temperature is going to be that largest value we have, 71. The lowest temperature is going to be that smallest value we have, 48. Range is the biggest minus the smallest, so that's 71 minus 48 gives you 23. The distribution curve, and this one's a little harder to see. It's not quite as obvious, and I drew a little sketch here, kind of what that's going to look like to let you know that that's skewed to the left. And how that stem and leaf plot helps you understand the data. What it does is it organizes the data and makes it easier to see the distribution. So those are a couple of things going through that. Hopefully those notes help you out on the rest of what we're doing today. Let's look at that real quick. All right, this is going to be the next page. I'm sorry that it's actually on the back of page 47. I'm not sure what happened with my copies there. Obviously, I messed up with it. So this is actually the back of 47. We'll do the front of 47 next. I've got the sheet backwards in there. What's going to happen, you and a partner are going to work on this. And I would prefer you actually to work with a partner if a group of 3 is needed due to the number in your class. You know, obviously there's an odd number. A group of 3 is fine, but make sure you're working with a partner on this because it will make things easier, but also gives you somebody to check against. That's especially important when you have so many numbers you're dealing with in the chart here. First off, you're starting with a stem and leaf plot. Now, I will tell you, I was nice enough to put all of these in order. There's no need to try to search and see if they're already in order. I promise you they are. They go down, from 39 to 46, and then from 46 to 53, going in order. What's a little different here is that we're not using the ones place this time. We're using the tenths place. So we got 39.3 over here is 39.3. You actually have a question about those values later, so make sure you pay attention to that. So your next one, going through, you only have one leaf on 39. Your next one, you're going to go 41.1, and you're going to go down to 41 and put a 1. Now, if you happen to notice here, we completely skipped 40, and that's fine. We're going to leave that there anyway. We're going down to 41. If you have any others you skip later, you're going to skip those down the list as well. So just showing you what's going on there. No, that's not a typo. That's supposed to be that way, and I'll talk about that a little more when I get back. You're going through the whole front side of this page answering questions. It's pretty easy questions if you've paid attention to the notes, and if not, you can go back. You're doing the back side of this page, which again is pretty simple, but I'm going to switch over to that real quick so that I can show you something. When you're doing the back side of this page, I only want you to focus on this top part up here. Only going to do number 4 all the way around here, doing that section. Don't cross out that bottom section. I saw some of you trying to do that. Don't cross out that bottom section because we're going to do that when I come back, but it'll be easier for me to explain on Wednesday and explain to you how that goes. So don't do it right now, but I'll show it to you later. That's part of your work. That's the part that's, can't talk. Need to be working on in class. You should have plenty of time to get through the notes and to get through that. Then we're going to jot over for your homework just so that you see what it looks like. It's going to be worksheet 48. And if you're working hard the entire time, you should actually have plenty of time to complete it all in class with a little time left over. If you're goofing off with your partner when you're working on worksheet 47, that could take you an hour. But if you're paying attention, that probably won't take you that long. Some of you probably worked on it before you saw that you were supposed to work with a partner. So, jaunting over to page 48 real quick. All right, again, not going to read through all of this because you can read, but stem and leaf plot for that first one, questions about it. You're going to need the stem and leaf plot to answer number 5, talking about that distribution. We're talking about the skewed left, skewed right, symmetric. Remember, kind of tracing over it can help you see that sometimes in finding the center. Also, looking at this bottom one here, if we it gives you a stem and leaf plot on this case, asking questions about it, and then wanting to know down here, difference between high and low score. I want you to remember that's the range, and if you don't remember what the range is, back these notes up. I talk about it towards the beginning when we're still on that notes page. So good luck today. We'll actually get to see you guys tomorrow, and we'll see you then.